Okay, we'll look at some of the homework problems in section 12.1, where we're dealing with triangles, and also we were dealing with some type of constructions that were briefly discussed on one of the lecture videos. Okay, in this particular video, I'll only assign like 3 problems in your homework. One of them is this: is it possible to find a circle that circumscribes each example of a regular septagon? And a septagon is another word for the heptagon, which represents a polygon that has 7 sides. And if it is possible to find such a circle, choose the correct example of the figure and its circumscribing circle. If it is not possible to find such a circle for every regular septagon, choose the correct counterexample. So if there's a counterexample, you want to find the one that doesn't fit this particular situation. And the word circumscribed is this: the circle has to be on the outside, and that circle has to touch each and every vertex of that particular polygon. In this case, we're talking about a regular septagon. So is it possible to circumscribe every regular septagon or 7-sided figure? Well, if you look at answer A, and by the way, in the homework you'll be given a choice of answers to choose from. Here's an example of a septagon, which is a 7-sided figure, and each vertex of that septagon touches the circle. So it is possible to circumscribe every regular septagon. And the example of that would be this selection right here. And it will be answer A in this case. This is a 7-sided figure, which is a septagon or a heptagon, and the circle touches all of those vertices in that septagon. All right, the next problem. Determine whether the conditions line segment PQ is congruent to line segment MN, line segment PR is congruent to line segment MO, and angle P is congruent to angle M, are sufficient to prove that triangle PQR is congruent to triangle MNO, and justify your answer. Okay, so here we want to find out, are the 2 triangles congruent? The best way to do this is to draw 2 triangles, triangle PQR and MNO. Okay, here are 2 triangles here. This is triangle PQR. And this one is MNO. And we want to mark off those congruencies. Like PQ is congruent to MN. So we're going to mark off PQ and MN like this. Line segment PR is congruent to line segment MO. Here's PR and MO marked off with the same markings. And angle P is congruent to angle M. Okay, so from that, can we prove that those triangles are congruent? And the answer there is yes. Because if you look at it, we have 2 sides and an included angle for the first one, and 2 sides and a included angle of the second triangle as well. Okay, so let's find out what that congruence condition is. In this case, it's side, angle, side. Also, side, angle, side for the second one. So here we're going to select SAS, which means side, angle, side, because we have 2 sides and an included angle of one triangle congruent respectively to 2 sides and an included angle of the second triangle. which means that triangle PQR is congruent to triangle MNO. Okay, and finally, is it possible to find a circle that circumscribes each example of a rectangle? And in this case, it would be by looking at these choices that are given to you. You can see here that you have a rectangle and and you have that circumscribed about the rectangle. Each vertex of that rectangle touches the circle. So here, that answer is yes. And pick out the correct example. That will be the correct example here. Okay, so this should be enough to assist you with the homework in section 12.1.